If you all have watched my channel for a while, there's two things you almost certainly know. One is that I've been changing databases in T3 chat too much, and the other is that I really don't like downtime. As such, this is kind of a sad video to make because we had our first major outage with T3 chat. In the past, we've had blips where as I was making changes, things were down for a few users for a few minutes. But we've never had anything before like we had this most recent Sunday, where for a couple hours, the site was almost entirely unusable. I want to be really transparent and straightforward with this. It's not acceptable. We take our uptime incredibly seriously, and we're going out of our way to make sure that going forward, you can use and trust T3 chat to be there when you need it. I was preparing the assets I needed for this video as I started recording, and noticed that Twitter is down as well. You literally cannot go to a feed and get posts. Apparently, I've never posted on Twitter, which you guys know is certainly not the case. Thankfully, if you have the direct link, it still seems to mostly work, and I've managed to find, on a very laggy, broken website, my original post taking accountability for this outage and describing what went wrong and how we plan to prevent it going forward, as well as a blog post from our friends over at Convex, because as much as I don't want them to shoulder the blame for this outage, there are things that they had implemented incorrectly on their side that caused it. I think this is going to be a very interesting video. It's not the usual why this tech is cool or how to prevent this type of error. It's going to more so be a breakdown of how we planned this migration, what issues we ran into throughout it, and what went wrong once we actually hit the go live button that caused these problems on Sunday. If you're interested in breakdowns of real engineering work with actual loads with hundreds of thousands of users, this could be an interesting deep dive for you. That all said, this costs us a ton of money and time, and Convex bills are now actually a thing that we have to pay. As such, we need a quick word from today's sponsor to cover some costs, and then we'll dive right in. Do you know what OpenAI, Anthropic, and Cursor all have in common? I'll give you a hint. It's not that they're AI companies. It's that they all use today's sponsor, WorkOS. Yes, really. You can see it if you go to any of their sites. Cursor uses the stock sign-in from AuthKit, which is hilarious, but also serves the purpose totally fine. And both OpenAI and Anthropic are using one of my favorite features from WorkOS, which is the admin portal. You could even see the URL here inside of Anthropic's official documentation. They're not hiding it at all. So why are all of these companies and so many more, including Vercel, Fanta, Carta, Fal, Replit, and more, all relying on WorkOS? It's because they got enterprise auth right. As someone who built the company that a lot of businesses are trying to use, I wish we started with WorkOS, and we're planning our move as we speak. That admin portal is killer if you're trying to get a big business to adopt your thing. Many of you probably haven't dealt with this before, but I have. Trying to set up everything from SAML to Okta and all these other weird abbreviations I can't even remember across different companies that all have it set up in their own weird different way across IAP. I wouldn't wish this on my worst enemy. If you're using WorkOS, you can just send them a link and they set it up however they want to at their business. There's a good chance the IT person at the other side has already used the specific admin portal because it's being used across so many of these businesses. By the way, cost isn't that bad either. It's free for your first 1 million users, which is pretty absurd. If you're ready to ship to serious businesses, check out WorkOS today at soydev.link/WorkOS. So let's start at a really high level. What went wrong? Like, what was this outage? Because it wasn't like people went to the site and then saw an error or a thing blocking the page. Problem was threefold. Primarily, the issue is that chats weren't loading. You would just sit there and nothing would load in. Creating new chats was also barely working, and honestly, just everything was lagging a ton. The reason for that was the WebSocket connection layer that you connect to with Convex was having issues. So the actual thing that sends the data down isn't just a traditional HTTP request. With Convex, you create a WebSocket connection on the client and subscribe to queries. So you get the initial data when you create the subscription, and then you get the rest when it changes and other things occur on the service. Problem was that that connection layer entirely fell over. In order to understand what problems we had that led to this place, I think a quick overview of this migration and what it looked like for us will make it a bit easier to understand. You might recognize some parts of this from the previous videos I've done about our database changes, but this will be an overview of why we are doing this. Before the Convex move, we had all of our data in a traditional MySQL DB. This DB was on PlanetScale. I still dearly and deeply love PlanetScale. I wish that they were the right product for us right now. The issue is that I found myself effectively rebuilding Convex on top of PlanetScale myself in order to make all of this possible. And that just wasn't maintainable for a 2.5 to 3.5 person team. Convex is a much bigger team with really talented people doing nothing but data sync stuff. And I wanted what they had, and it was a lot easier for us to move there than it was for me to rebuild all the things they did on top of T3 Chat in the database that we had before. The other important thing to understand is that the switch from the MySQL DB over to Convex sync engine is that this isn't just like we change where the data is stored. This effectively was a rewrite of the whole app. T3 Chat's about 25,000 lines of code. My PR changed 10,000 of them. This was pretty much a rewrite. As such, this wasn't just I changed the data store. This was an entirely new code base. And as such, I couldn't just put on a feature flag where your data would go to one DB or the other. This was an entirely different deployment with an entirely different experience for users. I could theoretically put a middleware on the URL and split which traffic goes to the new one versus the old one. But what I really wanted to do was a hard cutoff where we would pick a day and going forward, everyone would be on the new code base. And when a user signed in or opened the page for the first time, I would pull their data over to the Convex sync engine at that point. But that led to some problems. The initial implementation I had here was pretty rudimentary. The pieces are important to understand. So we had the traditional MySQL DB, we had the Convex sync engine. We also have the Vercel Next.js TRPC backend and endpoints. And then also we have the user client experience. These are the four parts that existed. We had the old MySQL DB that had all of the user's old data. And the way things would work before is we had that, the user experience, and the traditional DB with the backend in between. The user would make a request for their sync data. Request would go to the DB and do the drizzle call to get data. And this one was pretty lazy. I would usually just grab all of the data for you as a user. So all your threads and all your messages. We would then send back all data. And then that would go back to you where you would persist in indexed DB. IndexedDB is a data store in the browser that you can use to store data. All of your data used to be stored in the browser, but we ran into such an absurd number of issues as we were trying to do things for different browsers, getting Safari to work, getting multi-tab to work. IndexedDB just became a constant source of pain. There are whole companies that are just trying to make IndexedDB behave properly. Shout out to Dexy for making it usable at all. It was a phenomenal library that I love dearly. So much so that it almost tricked me into using IndexedDB for longer than we should have because the API just sucks. But this was our setup for a long time. Things are quite different with Convex involved, and it's going to look more complex initially, but I promise you it is not. People are also getting confused about the order being right to left, so I'm going to switch things over so that it's a little more logical. But the biggest difference is before we had the user client, then the backend, then the traditional DB, and the DB was behind the backend. Convex, you can kind of put it either side, but the place where you're expected to, if you're using it properly, is between here. You can even use Convex as your entire backend if you want to, because they have backend functions. So the way that things now work in T3 Chat is you query for thread data, get threads. That calls in Convex the right TypeScript function that you wrote, calls their database in order to get the data, and then sends back those threads. So this get threads call creates a subscription, and then we send back the data. And then if another change happens, let's say the backend sends an update to Convex that says thread name changed. Instead of me having to query the backend to know something changed, since Convex is connected via WebSocket, it would then send the change down to the user. That is updated thread data. And this is the magic of it. It made a lot of things way more simple, where instead of having the backend try to send the right data both to the user and to the database and keep everything in sync and hope for the best, the amount of edge cases, like something like deletions is so complex, because what happens if you delete a thread or delete a message on the client, but the server is still generating the result? What's the right state there? And if you open up another device that has that thread that you deleted on the thing you were on before, should it sync that back up? How does that all behave? And things like deleted messages reappearing, generated messages stopping halfway through and not restarting, all these types of problems were very persistent. And this was complex because before, the user would make a request to generate message, And the backend would effectively have to send it to you and send it to the database. Or, which we found what was much more stable, is it sends it to you, and then you afterwards would send it to the DB. Obviously, you would actually use the backend to do it, but the point I'm trying to make here is that the message gets sent to you, and then another function is hit to send it back to the DB. So if the client goes down, the backend no longer is sending it anywhere, everything sucks. But if I send it to the DB every time it changes, the write throughput is absurd. Getting the right balance here was really annoying. Convex made it significantly easier. You get the data, you're now subscribed. My backend can write changes to Convex, and you just get the update. Love this. Made things a lot easier. Still couldn't handle the absurd throughput that we were getting when we were generating messages, because these messages generate and update 300 times a second on some of these models. Like Gemini can do 200 to 300 tokens per second. So if we write all of that to DB and sync all of that down, you get the whole row every change. It's just unrealistic amounts of data. The place we landed is a nice hybrid model where the backend will stream the message to you as an optimistic update, but then it sends the final state to Convex, so you get that persisted. The results, much cleaner, feels really good overall, but that's not what we're here to talk about. I might do a whole separate breakdown of why I love Convex. Let me know if you're interested in the comments. But for now, I want to talk about the migration. So we now have all the parts. Here is how things would, for the most part, work with the migration, at least the first attempt. So user client would send this request to my backend that says, hey, I want to migrate. It would then do a few things. First, it would go to that traditional MySQL DB and get all data. It would send that data back. Obviously, it's a SQL request. That's how that works. User data. I would then chunk the data, and I would write all of the chunks piece by piece, starting with the chunks of attachments. So attachment, chunks, and it would do multiple. So if you had more than 100 attachments, it would chunk it into groups of 100. I would then do thread chunks. And then after that, I would do message chunks. And once all of these went through, I would do one last pass. That is the finalize migration. And this would just set a flag in Convex that says this user has completed their migration. Relatively simple, all things considered. And in all of my testing, even with really large amounts of data, this was working great. And once that was all done, you would get the sync event to the user that says, migration done. And now you can start using T3 chat. We got this all working. We were pretty happy with it. We hit the go button. And what happened the first time is a bunch of users got stuck in a weird state where the migration was continuing to loop. I talked about this a bit in my database change video before, but the TLDR of what went wrong is that the JWT we had for users who had signed in for the first time on a really old version of T3 chat, it had multiple different IDs in it. So we had subject, which would be a user ID. We also had properties, and properties was a nested object that had ID, which would also be user ID, as well as email, etc. So we were using subject as the identifier. The problem that we were getting was that users would run a migration, everything would seem fine, but then it would keep trying to migrate. The reason this would happen is that subject wasn't always the correct ID. Sometimes it was malformatted. This is because of a bug in OpenAuth, which was the auth library that we're using. Rolling your own auth is really fun until you run into these problems and then you question why you ever did it. I gladly would have paid the price for any other auth provider to have not lost the insane amount of time I lost to this bug. Straight up. It was not worth it. I regret rolling my own auth for this project, straight up. OpenAuth's a great library. I actually quite enjoy it. And it was the right thing for the time, for the choice, but this bug cost me so much time and money, it's hard to put into words. That was why the first migration failed. We started using this nested properties ID, which was always correctly formatted. That fixed a lot of issues. But I was nervous enough that we didn't want to just flick this on for everyone. That's why we introduced the T3 chat beta, where you could opt in going to a different URL, because remember, it's an entirely different code base. You go to beta.t3.chat, and you'd go here, you would migrate the first time you went, you'd have the little loading spinner saying, we're migrating your data. It would do all of this stuff, and you'd be good to go. That was much better. We had a lot of people migrate over. We kept a close eye on the traffic. We actually, crazy enough, had about 1/4 of our users move over to the beta, which was awesome. And I greatly owe all of the people who took the time to try out the T3 chat beta. It helped us a ton with understanding the performance characteristics that made all of this possible. That gave us the confidence that we were in a pretty good spot to hit the on switch and make the migration. So I tried again. It failed again. We were down for about 5 minutes. But that outage took down the beta entirely. So the beta was down for like an hour as things recovered. But I just flipped back to the old build. A couple people had to refresh twice because they got hit with this twice when we were figuring it out. But we had a lot more data to look into this time. What we found the second time we did the migration was that there was a huge throughput of mutations that were causing the problem. If we had 500 people on the website at the same time when this change came out, all 500 would run this at the same time. I wasn't doing any queuing beyond you would send your threads first, then messages, then finalize. But if 10 users did it at the same time, all 10 would go at once. The beta, somebody caught this in chat, yeah. The way that we did the beta effectively became a rolling update because users slowly rolled into the beta. So the traffic there, despite being representative, like if we just 4x'd our traffic from the beta, things would have been totally fine. But we didn't 4x the traffic from the beta. For 5 minutes, we 400x'd the traffic from the beta. And that throughput was too much. Or so we thought. This is actually where things start to get fun. We'll get there later on. Because we all, Convex and ourselves, had bad assumptions throughout this that had to be disproven at many points throughout the journey. This was now concerning enough to us that we realized we needed to queue these migrations. Instead of just running all of them all at once, we needed to parallelize it and put a limit on how many could run concurrently. As we probably should have from the start, but honestly, we thought we could make this hard cut, move on, and not have to worry about it. We were wrong. As I was working with Convex, they introduced me to a pattern that they had as one of their components. It was actually really cool and made this a lot easier. That pattern is their work pool component. I know the word component is confusing for us as React devs, but their idea of components are these pre-made utilities that they built that work inside of the Convex context to do different types of work. And work pools are incredibly cool. You create a work pool by defining it in your app config. So now I have components.migration work pool. This is a defined thing that exists in my app definitions Convex config here. So a work pool that we defined here with the name migration work pool. This all exists. Now I can call this other places like here where I define migration work pool with a max parallelism limit of 10. So this can only run 10 things at a time. Everything else will get queued if you try to queue up more stuff. And now I have queue migration work, which is an endpoint that a user hits when we detect they should be migrating. We throw if they're not auth, which should never happen due to the way I fixed and set up auth stuff. And now they call the work pool with an enqueue action. This queues up some work to do in the work pool with a given set of arguments. And since this is Convex, this internal migration thing, this is just an API that I defined, and I can command click and go to it just like you do in tRPC. Super nice. All type safe as well, of course. Do migration action is an internal action, takes in a user ID, finalize so that I can run this in the background and not finalize the migrations, as well as the user prompt customization and the user configuration because those weren't stored on the server before, so I need a way for the user to be able to send that up to start the migration. I then fetch your data from our backend, which is a bit annoying. The relationship between Convex, the backend, and my backend on Vercel is the single thing with Convex that hasn't been my favorite yet. It's nice because it is just JavaScript, so you could do something stupid like give it an environment variable for the URL you're deploying to and have it work. But in dev, this was annoying, and I actually still have an ngrok tab open in my terminal here. You'll see number one, the bottom there is ngrok, because that's how I would have Convex call the backend in order to get the data that we have to migrate. I even still have the header to skip ngrok warnings for this in there. I would then error out, so I have logs if it fails. I would then parse it with super JSON parsing. If it succeeded, I use super JSON instead of normal JSON, so things like date times will be in the correct format. I don't have to convert from number to date. I log how much stuff we're about to do. And now here in this action, I go through each chunk and I migrate it. I go through each chunk of threads, I migrate it. I go through each chunk of messages and I migrate it. If they have prompt customization, I include that. And if they have user config, I include that too. And then I finalize it if the finalize is set to true by updating, we're calling the wrap up migration function, which just sets on the user config that the migration is done. Pretty simple. And it's actually really nice with Convex that this type of code isn't some crazy custom syntax. It's just all if this thing, for loop, do the thing. It's one of my favorite things about Convex is you are just writing TypeScript, but you're not taking a performance hit for it. That is meaningful. It's really, really nice. And since I put this in the work pool, this migrate action can only have 10 running at a time. So if a new one gets queued up, it just sits in the queue and waits until the other 10 are done. So it's impossible to have more than 10 of these running at the same time. I was concerned enough with our launch that we actually bumped it all the way down to 3. And then we shipped. And it worked. At least we thought. About 5 minutes in, performance went to shit again. And this time I felt really bad. There's an additional detail I forgot to include here, which is that our traffic for T3 chat fluctuates a lot throughout the day and week. On weekdays, midday, the traffic is at its highest by far. But on weekends around midnight, it's a lot less traffic, about half as much. As such, we plan to do the migration around midnight on Saturday night. Then I went and double checked the data, and I saw we were in the lowest point when I checked, which was around 5 p.m. Turns out I was looking at UTC time, even though I was certain I had post hog set in PST. The low point was midnight UTC, which is around 6 p.m. my time. So I made the executive decision to migrate us then, because I wanted to do it during that window of lowest traffic, so it would be the smoothest rolling migration possible. And it went well for a little bit, but quickly users started having issues. People weren't able to connect to the WebSocket layer. Queries were getting really slow. It was getting really bad. And when I looked at the numbers, it looked really bad. The query throughput was absurd. And most importantly, and this was the really scary part, when I went to the dashboard, it would lag out and crash. And the Convex dashboard is a lifesaver. It's so good. So having that not working was terrifying. I felt like I had no idea what was or wasn't functioning for our users. So I made the decision to roll us back again. This was the third failed attempt to migrate us to Convex, and I was bummed. Unlike my other attempts, Jamie, who's one of the founders at Convex, was not around to help because he was out at a movie with his family. And I felt so bad. But despite that, he actually left the movie and sat on a bench and debugged with us on his phone alongside his other co-founder, James. And we found some really important details. It turns out the query throughput was one of the biggest issues. This was the load. We did the migration right around 7:30, had a spike then, it chilled out, then it spiked a ton, and that's when it crashed. We were absolutely within the right limits, especially now. Previously, we were pretty convinced the problem was the throughput for writing mutations. That was certainly some amount of a problem, but it wasn't the problem that was causing the issues that we were seeing. It certainly wasn't the problem that caused our queries to flatline to 0 because of the throughput. The issue ended up being a couple much more subtle things. The way Convex works is I get the threads when I call the getThread function, and now I'm subscribed to that set of threads. If a change happens, the update comes down. What happens if these threads are all being updated constantly because a migration is running? You have a lot more data being sent to that client and a lot more queries being fired because every time you write one of those rows inside of this response, the whole response gets sent back down. Turns out I actually made things way worse for myself with another change that I had made. Something I care a lot about is really snappy navigation. I want you to, when you click a thread in the sidebar, have it immediately show the messages. The way I solved this is I had this function here where I would grab your top 20 threads and I would return my thread prefetcher for all of them. My thread prefetcher is just a use session query for the messages for that thread, and it returns null. This is a component that renders nothing, that exclusively exists to subscribe to the threads that you have in your sidebar there. I could do some fancy stuff with hover prefetching and all of that. I didn't want to. This ended up being the simplest, snappiest solution by far. But now we have 20 subscriptions to your top 20 threads. And we were migrating oldest to newest. So let's walk through what this now looks like for the client when the migration is going like this. Migrate all the attachments, nothing happens. Cool. Then we migrate threads. Migrate 100 threads. Top 20 get subbed. So top 20 now create queries to get messages. And then another 100 threads come in. Now the top 20 changes. New 20 queries to get messages. This would happen until all your threads migrated. So every time a chunk of threads came in, 20 queries would fire and or update. But that wasn't the worst part. The worst part is when we moved to message chunks. Because if those message chunks, if any of them touched those top 20 threads, you had those top 20 thread listeners waiting, and all of the message writes would update some number of those. So the message chunking was firing hundreds of additional queries, And all of this was happening in the background as the migration was running. So you as the user weren't benefiting from any of this data being fetched. We were just subscribing to things we shouldn't have been yet, which caused absurd amounts of query traffic that we didn't need. Why did we not catch this before? How did we have this going that poorly and not notice? Remember earlier when I was talking about this auth issue? There were two parts of this. The first part was that subject ID mismatching thing. The other part is that our cookies used to be HTTP only. And when the migration was running, it would still be an HTTP only, which meant that we couldn't use that cookie to connect to Convex. And I would update the auth after the migration was completed. So anything we were doing in the client that was dealing with subscriptions didn't matter because you weren't connecting to the client yet. You didn't connect until after the migration was done, where we would then update your authentication. As such, you never had to hit these queries in that case. But I fixed auth earlier because now I didn't have to trigger through my backend. Now I'm triggering by calling Convex directly. So I need auth fixed first. So I fixed auth, then I connect to Convex, then I trigger the thing. But now you're connected to Convex. So now we had these insane loads of just tons of queries updating that didn't need to, causing you to do a ton of traffic that you didn't benefit from, that just caused us to effectively DDoS the database layer in Convex. The correct solution for a lot of this would have been very simply to not render any of this until the migration was completed. I even added this here for that reason. But I also added this too, which we'll get to in a bit. When I pushed this, it reduced the load by between 40 and 70x. This one line of code where I don't prefetch if you haven't finished migrations. That one line change made everything go significantly smoother. And at this point, for the most part, we were out of the woods. Things were smooth. The app felt great. I was really happy. I made a couple more changes before going to bed that night because I wanted optimistic updates to be better for people who aren't near the server so that when they made a change, they would see it in the UI faster. Ended up making it feel significantly better. I'd even say it's faster than T3 Chat was before when it was local first. Was very happy with where things were. And for the first time in a long time, I slept good. I straight up slept for like 12 hours. It was from like 10:30 p.m. till 10:30, maybe 11 a.m. the next day. I slept hard because I needed it after a month of getting all of this done. And I woke up to utter chaos. I woke up to so many DMs, so many support emails, so many tags, so many messages, so many replies on Twitter, so many Slack messages and threads. Between 6 and 8 a.m., things had started to really slow down. And from around 9 a.m. onwards, things were effectively down. We had mitigated pretty much everything we could at that point. And I would argue from here forward, there wasn't much we could have done to prevent the failures. But to be very, very clear, it does not mean we aren't responsible. We should have been able to recover much faster. And the fact that we didn't have a good enough paging system to wake me up earlier is a huge failure on my part, and we are going out of our way to fix that. So going forward, I can get these things fixed much faster. This is where the problems got significantly more complex. I could tell you from my own words, but Convex actually went out of their way to make their own blog post detailing what went wrong here, because our load was very interesting. Up until this point, the issues we had had were, for the most part, code we wrote that was bad, causing either weird shapes for authentication data or queries and mutation throughput that was just absurd and unreasonable, especially at our size of product. Those were almost entirely our things to fix, not Convex's fault. There were even a few times where we were convinced it was Convex's fault. They went along with it for us to figure out it was actually us in the end. Wild set of experiences, but this was a very different outage. The fact that we had so many problems with the mutation and query throughput kind of led us down the wrong path when we started having problems here. I love the wording here. Despite what Theo's discount code might lead you to believe, none of this was Theo's fault. It was Convex's fault. I don't like that. I think we all have things we can improve here. But this outage was like things that no one expected on either side to cause problems. We'll get to those in a bit, because as I said, our traffic should totally fit within what Convex can do, but there are quirks to our traffic that they were not prepared for. Speaking of discount codes, if you haven't subscribed to T3 Chat yet, you can subscribe now with the code BLAMETHEO, and you'll get your first month for just $1. Only for new subs, and don't ask us for a refund on $1. Come on, guys. $1 for a full month when it's normally $8. Get access to all those models. It's a pretty good deal, I think. give it a shot. Anyways, vast majority of Convex is open source. So this is actually a really cool point. We can look at the diffs on Convex when they fixed these things and made these changes. Also funny, a bunch of people tried using the coupon code Theo to get a discount on Convex. Convex doesn't really do much in terms of discounts. And to be fair, it's really cheap. I don't know why they would. And their free tier is really generous too. So there's a discount code for Convex from me. But let them know that I sent you if you do try them out because of me, because they've been awesome. I was so skeptical of Convex for like 4 years. And I came around and I can't imagine building stuff with my stack without it now. So here are the pieces that made our traffic weird. The first point is that we do a lot more text search than other high traffic Convex customers do. We have a search right there. People really like to use it. It's not in a great state right now because we turned off indexing on messages. So we're only searching based on thread titles right now, which I hate. We will fix this very soon once we are sure the traffic spike is something we can handle. But the search box was causing problems. But the bigger issue, and this is what none of us expected at the time, users frequently leave T3 chat open in a background tab, so it's there when they need to go check it. This was the problem, because a lot of people who weren't actively using T3 chat were still connected via the WebSocket connection. And despite our actual throughput being relatively low, the number of WebSocket connections we had was absurdly high. As people are saying in chat here, T3 chat's open all day for me. Same for me. I have a bunch of T3 chat tabs open at any given time. People, same, it's open 24/7. I do it on multiple devices. Yeah. Any given T3 chat user has a chance of having like 5 tabs open across different devices that all have an active connection to the WebSocket layer. Thankfully, and I'm very thankful this is the case, when you implement WebSockets correctly, a given WebSocket connection is actually really, really cheap. So theoretically, if we have a ton of these connections at any given time, it shouldn't actually matter too much in terms of the load on the Convex server. And as we've mentioned many times now, Convex manages all of the data back and forth on the client through the WebSocket. An important piece they have here is that as they've scaled up customers, they've slowly accumulated a vast list of knobs. These knobs are runtime customizable parameters that they can adjust on a case-by-case basis so that larger customers can scale smoothly. There are things like resources, cache sizes, limits on a given Convex deployment. And they literally link the Rust code for the backend. Yes, Convex is written in Rust for their crazy scalable WebSocket backend. And they link the code that shows all of these custom knobs that they have a configuration for so that they can change the performance characteristics for a given deployment when it needs it. And they had bumped a handful of things for us to make sure everything went smoothly. They did call out one more detail here. And as far as I know, this didn't end up being too big a problem. But their text search doesn't scale as aggressively as the rest of their stuff does. So for us, with a shitload of text data that needs to be searched against, they found some edges they're still working on fixing. And I'm sure it'll be fixed very soon. I haven't even bothered trying to turn it on to see what happens yet, but it should be good soon. The important piece is that we had made so many WebSocket connections because people would join T3 chat, open it up, and just leave it open. The number of WebSocket connections we had was just going up more and more over time and very rarely going down. It was a pretty consistent growth there. Around 6 a.m., one of the Convex on-call engineers noticed elevated error rates for some T3 chat users. The error subsided and load returned to normal, so the investigation was tabled until more engineers were online. It started to ramp up bad around 8 a.m. But by 9:30, the errors had returned significantly. With several engineers online, the team realized that a new limit within the codebase was being hit as more T3 chat users were waking up and using the app. The number of pending subscriptions that needed to be refreshed. T3 chat was periodically having giant spikes of query invalidations and server function runs. With more users online, these jobs were starting to overflow a queue of waiting during spikes, which caused the server to drop WebSocket connections. So the pattern that happened here is that their text indexing would invalidate itself every 30 minutes. That would cause the queries to have their cache busted, which would then send an update down the WebSocket. But there would be a huge queue of those when that happened, which would occasionally cause the WebSocket connections to drop. We didn't understand why T3 chat was sporadically going from a steady state load of 50 QPS to 20,000 plus per second. But our first instinct was to turn this hard-coded queue size limit into a knob so we didn't cause all the clients to crash and reconnect. That would buy us some time. So the problem here was that the number of connections that could exist at a given time was hard-coded still. They hadn't made it a knob yet. So they changed that so they could configure it. And they bumped our limit from 10K to 100K. Then around 10:15 a.m., they simulated the failure that we were having, and the engineer team noticed that the Convex client didn't back off when this particular failure occurred. This is probably the most important, and I would argue the most interesting detail of it all. As you can guess, connecting to that Convex client and managing all the state on client is annoying, so they have a really nice JavaScript library that does it for you. It also manages the connection. The connection, when it fails, has a schedule reconnection function that does an exponential backoff so it doesn't DDoS the service when it is struggling to connect. The problem is it doesn't call that properly under certain cases. And the subscription worker full error that caused these failures was one of the ones where it wouldn't exponential backoff, it would just rapidly try to reconnect. So their client code wasn't backing off when the connection failed. And because of that, it was DDoSing their servers. So Convex's code in T3 chat was DDoSing Convex's WebSocket connection layer. They rushed out a change to fix this. Again, huge shout out to their team, especially Tom, who was making a bunch of changes on the JavaScript side in order for us to get this fixed. We shipped 2 custom clients out that they pushed to NPM just for us to get this underway. The problem was a lot of users were just waiting for the page to recover, or they had a background tab. We couldn't force refresh the user's client. You've all seen that little notification in the corner that's like, T3 chat has an update, click to refresh. That's all we could do. We couldn't force a client to update, which meant a lot of different clients were on an old version of this JavaScript package that was DDoSing their service. And we had to wait for more and more of those clients to be updated to have the new code that would back off more gracefully in hopes of reducing the connection load. As they said, unfortunately, most of this load was coming from background tabs, and we had no mechanism to force a refresh on those tabs. So the old Convex code kept hammering the backend, which would overflow the queue, causing disconnections and reconnections yet again. Around 10:50, they had finally finished building and passing all the tests for their backend, which, funny enough, since their backend's in Rust, it's a lot harder to ship because the build times suck. Welcome to Rust. It's funny that Rust is going to fix our build time problems in JavaScript while having its own massive build time problems. Eventually, the backend was ready. They shipped it, and now they could increase the size of that queue, which seemed like it would solve all our problems. But another problem was introduced that we'll get to in a bit. From 11 to 12, the Thundering Herd just continued to overwhelm the T3 Chat Convex deployment. Couldn't figure out what was happening. We profiled the app. We found several optimization opportunities to speed up the Convex engine. I found a bunch on my end too. That's where this came from. If outage, return null. I went through and found all the heaviest things in the app that weren't necessary and disabled them, commented them out, blocked them, and did whatever I had to just make the app do less traffic. As people are saying in chat, they saw a whole bunch of update notifications right as the outage happened. And all of those were us changing the client bundle, shipping changes to try and reduce load, all these different things to do our best to recover. I'll be honest, at this point, I was thinking about once again rolling back to the legacy version, but no part of me wanted to go back to the old DB, the old index DB indexy setup, and have to have people lose their chats they did in the last 12 to 24 hours. I needed to make this work. And we felt like we were so close constantly. I was scared, but I knew we could do it, and having the whole Convex team up and working with us was a huge relief. Somebody asked, why not implement force reload? Because we couldn't implement different client code if the client was out of date. Even if we did add force reload then, we couldn't run it on old clients. We had no code on the user's device that could trigger a refresh. So we had no way to get these old tabs updated. We should have it now, and we'll probably do something in the future to make it more likely. But yeah. And thank you for this jolly coding, because I feel terrible about this outage, but both Claude and Twitter were down for more time last week. So I'm being too upfront, and if anything, this might actually look bad for us, because both Claude and Twitter are pretending their outages didn't happen, and people are forgetting about them. Most users probably didn't encounter the outage that I am describing because it was on a Sunday, which is our lowest traffic day. But I take this really seriously, and me talking about it so much will probably make our service look less stable than our competition, even though our uptime is comically better. But I'm not trying to rub it in. I'm trying to be transparent and as honest as I can be about what happened. Well, because I think it's interesting, and because I want you to know what we're doing to fix it so you can trust us going forward. I think that's much more important than pretending we don't go down. Anyways. They found some changes on their end to jitter and back off connections to try and lower this insane amount of load, but they still hadn't quite discovered the third problem. Here is where that was discovered. An engineer on our team noticed that while we were manually pushing out fixes to T3 Chat's Convex deployment during the outage, we accidentally placed the deployment back onto the default hardware resources used by free accounts. So the issue at this point was both the insane reconnection load, but also that we were on the free tier effectively because they were doing so much manual stuff pushing. It was just an honest, simple mistake. The problem was that their system that kept track of which provision a given instance was on was overridden by the custom deployments they were doing because it just didn't honor that setting. Honest mistake. I have made so many mistakes like this. It's hard to even put into words, especially for like account provisioning for like when we change someone's tier on ping. I cause bugs like this dozens of times a week. I don't hold this against them at all. I'm pumped they found it though, because like this is an annoying thing to find. They debated fixing it immediately, but it felt like the weaker hardware had almost gotten the site back online, so we delayed fixing that issue for a few more minutes to see if we can get everyone in sync before restarting the backend yet again. Because restarting would once again cause all those old clients to go back into DDoS mode. And if we can get enough of those old clients connected, they would stop DDoSing and the traffic would be much more reasonable. But then they saw it still just wasn't recovering fast enough, so they finally made the decision to redeploy on the much more powerful hardware that makes more sense for our service, and it was almost immediately recovered from that point. That was the timeline, but they did a much deeper root cause analysis. I've touched on a lot of this throughout. I want to break it down because they did a great job. The first piece was their search index compaction causing query invalidation. This was really funny because they sent me this graph where they showed spikes every 30-ish minutes that were just insane. And I was very confused about them because we didn't even see them in our dashboards. And James asked if we had a cron or a scheduled job or something that was running every hour or every 30 minutes that would have been causing this. I don't know how much you guys know about the stuff I build, but I avoid scheduled work to the best of my ability. A cron is a liability in 4 letters. The amount of problems I have had from old crons running that we forgot about is hard to put into words. I much prefer things to be driven by users, not like automation. Somebody asked if James was the on-call engineer. No, James is one of the founders. The founders of Convex were the ones in the trenches helping with a ton of this. James was the CTO and Jamie was the CEO, and they were both deep in this helping us. This wasn't like some random on-call engineer desperately trying to help us out. This was the core of Convex putting everything aside to make this work for us. And somebody just asked, should you close your background T3 job? No, do not. Keep T3 chat up and going. Do not change the way you use T3 chat based on what you learned today. T3 chat should work however you want to use it, and if it doesn't, tell me and we will fix it. We will continue finding all of these things and fixing them. Yeah. So this one was funny because honestly, when you see a chart like this with 30-minute hits, and it's any other customer, you would assume they have something on a cron job that's causing it. That is the reasonable assumption. I would have made the same assumption myself. We do not have a single cron job running for anything on T3 chat, so this couldn't have been us. And then, I love their wording here. We did what comes naturally, accuse the customer. I want to give Convex an absolutely absurd amount of credit here because I have come to them with so many things that I was 100% confident were things they did wrong. And of the 6 major ones where I did that, 5 were our fault and 1 was OpenAuth's fault. So of the 6, what the fuck are you doing Convex moments I had, all 6 weren't their fault. These guys really, really get databases and scaling. Even if it seems like this is a massive failure in scale, do you know who doesn't have those problems? PlanetScale. Do you know who the pickiest person I know is about database stuff? Sam Lambert, the CEO of PlanetScale. I introduced Sam to James and Jamie, and he said to me, I don't even know if I'm supposed to say this, I don't care. If I could possibly hire them, I would. It's rare I get to talk to people who don't work for PlanetScale that understand database scaling and characteristics as good as they do. It was a relief of a conversation to have. So if you're thinking of Convex as this like JavaScript bro database solution or like a Firebase alternative for small apps, you don't understand. Those guys scaled Dropbox and they built Convex on what they learned. They really get what they're doing. And right now our Convex deployment is also based on MySQL. And there's a possibility in the future, they're in talks, they've had it back and forth public about it. I hope that happens, where there's a future where Convex is running on PlanetScale. So I'll once again be back on PlanetScale, as funny as that would be. We'll see if that happens. Fingers crossed. We'll see in the future. But they know how to scale. So do not think any of this implies that they don't know how to do scaling stuff. We just happen to have weird workloads that hit specific edge cases that they could immediately just turn up a knob and it handled the scale fine. So James made the mistake of accusing us, not knowing I don't do crons. And this is something that I would expect from them because I've accused them so many times of things that weren't their fault. Yeah, this was totally reasonable and understandable. And you can see my sleep schedule showing off right here yesterday at 2:55 a.m. Also, them at 10 p.m. still trying to help us with debugging. Any luck figuring out what those spikes are? I'm curious, not seeing them ourselves on Axiom. Yep, we got them. It's a search index cache entry invalidation. We'll add this to the postmortem post and also prevent them from happening. Their search indexing was running compaction in order to keep the data size smaller for all the index fields, but it was updating every 30 minutes, which would invalidate subscriptions, which would cause a bunch of queries to fire. For those wondering what Axiom is, it is one of my favorite services. The first two companies to really pressure me into considering a sponsor deal were Upstash and Axiom, because both of them were super hyped on me and what I was doing when I had like 1,000 subs on YouTube. Love those guys. And if you know my community, you know that they have taken a ton of people from here, including CJ, who's one of the core people for Create T3 app, Igor, who's one of my favorite designers ever, and Gabriel, who used to be my lead researcher and now is too busy running a bunch of engineering stuff at Axiom. Love those guys. Really, really good platform. And I'll be honest, I had not used it much since they redid the dashboard until these outages. Here is their query builder UI. The big thing with Axiom is it just can handle horrifyingly large amounts of data. Like if you look at their pricing, you'll understand. You can ingest 500 gigs of data per month for free. What? What? It's so insane. I have been very, very happy with Axiom as our like log dump for everything, including all of Convex, because Convex actually has a integration with Axiom where you just click the little attach button and now all of our logs go straight to Axiom for us to do what we need to with. So here we're going to grab all of our executions where there is a data function path that exists. And now when I hit run, it's going to show me all of the queries that have run. But I want to do a bit more. I want to count based on the given function that's being called. So if I change this to data function path there, and I hide my screen in case there's PII in here, and there we go. Now I can trivially, based on a given function path, create a graph to see what our traffic looks like at any given time. I can do last day. We can see spikes that occur throughout the day and all the different traffic for all the different functions. And as you can see, search gets hit like 1.7 million times a day. I thought I had nerfed that. I guess my nerf didn't go through. I'll have to go adjust that later. But get thread by ID gets hit 1.5 million times a day. You get the idea. We do a lot of traffic right now. This is such a nice way to visualize this data. It's such a good service for just logging everything. Axiom's cool. You should give them a shot if you haven't. They're not sponsoring me right now. I have turned it down over and over. I probably should. They're doing well. I should probably hit them back up. I really like them. It's been nice for that. But as I was saying, we did not see the spikes that they were seeing when I went and checked inside of Axiom, which meant it had to be on their side. So they asked what the logging code looks like. What code? Here's what it looks like. You go to settings in Convex or Vercel or whatever else, and you connect to Axiom. Now there is no code, and all my logs just go to Axiom. It's very, very, very simple. No effort. That's part of why I like them so much. That's how I got everything from Convex to Axiom. Sorry for the deep dive on all that stuff. People were asking questions, and I thought it might be useful to see how we actually monitor these things. It's like if Grafana or Datadog didn't cost billions of dollars and had an interface made by people who actually care. Anyways, the problem that we were discussing first, the first of the 3 problems Convex listed, was that search indexing problem that was on their end. They didn't notice how often this was happening because Convex is really fast. So they didn't notice until the number of queries got bigger than the queue size, which caused the clients to go into these retry loops. Problem 2, the backoff logic. I talked about this before, but it was not nuanced enough. If it successfully makes a connection of any form, it would immediately reset the exponent to 0. The problem was it would connect, get an error, then disconnect, which meant that it would reconnect over and over again. Every time it managed to make a connection, it would be disconnected and then recreate it. So that exponential backoff wasn't applying because the exponent was being set to 0 over and over again. So it ended up causing a DDoS to their service. As they said, if they had the backoff working, T3 chat probably would have gotten back to running properly again, even on the free tier, cheaper, lesser quality hardware. But that leads us to problem 3, which was that operational tooling did not enforce account-specific provisioning rules. So when they were in their like ops dashboard for putting out this emergency, it didn't persist settings that they had set on my account, which were in this case the settings to be on a more powerful box. As such, things fell over because it wasn't a powerful enough box to handle our traffic. The tool that they used to push code manually in their clusters during an outage didn't preserve the provisioned resources that they had applied before on the account, and they forgot to manually override it when they were hastily trying to fix it. This is a mistake that only happens when you are trying really hard to fix the thing, which is again why I will never ever fault them for it. They were trying so hard to fix the thing that they found 3 bugs in their system because they were trying to fix it that hard. We spent more than an hour looking for complicated architectural reasons the T3 chat was down when the issue was actually the simple CPU overloaded because it was running on the wrong VM type. Humans are allowed to make mistakes, especially under stress, so tooling needs to protect them from those mistakes. This is the part I really want to emphasize. I do not fault Convex at all for any of this. I will take as much fault as is possibly reasonable, specifically because we also didn't have good enough tooling, not just to prevent mistakes, but escalate the problem when we discovered it. None of that tooling was in place yet, and we are working hard to do it now. We're going to go through their follow-up actions, and then we're going to go through what we have planned on our side too. Convex's follow-up actions for the immediate are to make sure all tools honor codified hardware classes and resource assignments per deployment. So you don't have to worry which tool you're using internally at Convex. You know that the setup will always be honored. Optimize the search indexing compaction so it doesn't invalidate queries when no data actually changed. And ship a new client library with more comprehensive backup behavior. I think they already did this. Honestly, they probably did all 3 of these by now. These guys move fast. Going forward, they plan to do CPU optimizations for subscription engines so that the keys are stored rather than being computed at the read point, which will be a huge compute savings there. They also want to make new benchmarks and load tests around the DDoS case that we hit. Add server-side buffering and back off on Convex sessions so that the server can slow your connection down so you don't have to worry about the client causing the DDoS. And of course, add more configuration for dropping WebSockets from inactive tabs in the Convex client so that instead of us having to write some custom code so that the background tabs disconnect, they can automatically disconnect when they're seeing it run in the background and then reconnect when you open it back up. This was an awesome post. Huge shout out to Jamie for writing it and to James and Tom and everyone else at Convex that helped out throughout all of this. They've been essential not just for making the migration happen, but helping us debug things internally in the app, go through a deeper understanding of all the things Convex does and doesn't do. And now with an outage like this, I really felt like all hands were on deck to make this happen. There is nothing I would have asked for more from Convex throughout this. They took this more seriously than I ever could have expected or asked. And as you guys know about me, I might be a hard ass, but I am so incredibly forgiving. If you make an honest effort to fix something, I basically will never hold it against you. And they have made such a deep effort here that you should be more likely to use them seeing it, not less. Knowing they care this much about their customers, even small, in quotes, ones like us, should show the depth of how hard they work to make sure Convex is the right solution for everyone who uses it. So what can we do on the T3 chat side now? Well, the first thing we can do is fix fucking Twitter so I don't have to scroll back up every time I open this tab. But once Twitter's fixed, here was my breakdown. I posted this literally as we were recovering. We said we were live at 12:45. This post was 12:49. My goal was to be as transparent as possible with where we were at and what we knew at the time. I called out that we were pumped to finally have this migration done. We did it during the lowest traffic window. Everything seemed fine. I slept for 12 hours. The biggest piece that I called out here was that WebSocket connection DDoSing thing. But here are the things I plan to fix. First big one is an actual status platform and update plan, as well as reporting in app. Should we have a status page? Probably. But you should also know in app what's going on. We should have a way that is separated from every other system to tell you inside of the app, hey, here's what went wrong today. Here's what's going on. Here's what you need to know. We're still figuring out where to put it in the UI. It's more a design problem than anything at this point, but we'll have a place in the UI to let you know, hey, some messages that are older than this time might have failed to migrate. Go to settings and click this button. Or, hey, we're mitigating an outage with Claude. Claude models are degraded right now. Or in this case, hey, everything's fucked. I'm sorry. We'll be back in a minute. We really want to do this. We'll have it very soon. Least we can do. Probably should have had this a month ago, but the way things were built didn't make a lot of sense. And also our outages, by the time we knew about it, we were halfway done fixing it usually. And it would take 5 minutes for us to fix half the time. Most of our outages Other than this outage, all of our outages have been less than 5 minutes. Status page doesn't help a whole lot for that. Point 2, we need a paging system. It's funny, I do actually have a paging system built, but it's a custom implemented thing I did for myself that I gave a couple community members access to so they can page me when a new model comes out so we can have it shipped immediately. But we don't have anything for an outage. And I was asleep cozy in bed for most of this outage. I don't like that. Not because like I'm the only one who could fix it. Clearly, like I did almost nothing here other than comment out some functions that cause a lot of load. I just want to be there to run comms and help the team when these things occur. And sadly, there was not a good way for my team or their team or anyone else to page me when things went wrong. I also want to have automated error detection, so I'll get paged if error rates go up too. We're finding better places to sneak all of that in. The biggest problem there, funny enough, is that most of our users use ad blocks. And since our service is now popular enough, whenever I pick an endpoint to send things like analytics data or errors from Sentry to, the ad block lunatics will block those analytics endpoints and those product feedback endpoints that we use to know when errors are occurring. I can't tell you how many times a user said they had an error. I went to the logs. I'm like, we have no logs of that. I asked if they have an ad blocker and they're running Brave every fucking time. It's so annoying. I understand users wanting to protect their data. I do not understand blocking Sentry from sending logs because you installed an ad blocker. It is not intuitive to a user that installing a tool to block ads means that the products you're using don't know when you encounter errors. Those don't line up in a normal person's head, and it really sucks because no matter what I do here, I don't feel like I'll have a good way of tracking client-side errors ever because so many of our users are on ad blocks. And you should be. Ad blocks make the internet more safe. But maybe if you're down, unblock our endpoints. Gabriel said, aren't the servers proxied? So this is a common thing. We're deep in the weeds. I can go deeper. Why not? Usually when you use something like, I don't know, let's use PostHog as the example. You have client, you have Vercel backend, you have PostHog or Axiom or Sentry or whatever else there. Grab my lines. User does something on the backend. They get a response. Then the client errors for some reason. Something goes wrong on the client. They try to contact PostHog, but PostHog is hosted on like us.post, or I think it's us.posthog.com/event/whatever, and then like the event information. This URL is blocked by every fucking ad block in the world. Very annoying. So what most sites will do, and this is basically necessary nowadays, is you create a proxy on your own backend. So I send this to /API/event or something, and then this gets proxied to then go to us.i.posthog so that the data, despite the ad blocker blocking it, they're blocking this URL. They're not blocking an endpoint on my service. The problem is every time we change which one of these paths we're sending these events to on T3 chat, the new path gets set as a blocked URL in all of these block lists. So it doesn't matter whether or not us.i.posthog is blocked because right now, t3.chat/API/event, this URL is currently blocked in every ad blocker. I want to die. I can change it again. I will continue to change it over and over. The other thing I could do is I could send this data down an endpoint that's used for other things. Like I could send it down API chat, which is used for sending messages, and just have a custom flag on it for these other events and proxy those manually that way. But I don't want to change our architecture in those stupid ways because users are being that dumb. I really don't want to do that. I might have to in the future. How do they find out it's proxied? They open the network tab and they watch what traffic goes where, and they test blocking things on their client and see if T3 chat breaks or not. There's basically nothing we can do to prevent this, sadly. It used to work great to just proxy it to a different endpoint, but they'll block the endpoints now too. So our only option now is reuse the endpoint for other things and risk them still blocking it and then breaking T3 chat. So yeah, if people are asking, is this targeted? This is absolutely targeted. If you're popular enough or the people who pay attention to you are involved in the ad block communities and don't like you very much, they will obsessively do this. The amount of time it takes from when I change this URL to it being blocked right now, it's about 24 to 72 hours because these people are obsessive and insane. As such, I don't actually know when most of our users' devices hit an error because we don't get the fucking event. So yeah, that sucks. I'm going to put effort in to fix that because I want to know when things error. But thanks to ad blocks, it's basically impossible for me to know when a client-side error occurs. I can only know on the server. I obsessively log our server errors and I track them and make things change every day because of them. But I want to know when you're seeing an error so that I can be paged when enough users hit an error so I can wake up and go fix the thing. I'll have to put a lot of work in thanks to ad blockers to make this happen, but I will. One other piece is something that came up in the Convex article. We need a way to have a refresh to latest flow on the client. So we can't rely on you clicking the refresh button if things are broken. I need a way to, in an emergency, force your client to disconnect or ideally refresh and get on the latest version. I also, very big deal, need to go through all of the providers that we currently rely on and make sure that they are prepared for the load and the load characteristics that we have, especially now because we are scaling like mad. T3 Chat is still growing in ways I never could have expected. I never would have thought this service would be the thing that is the, not just like funding my company, but is now paying us back well enough that I can bring on an intern for the summer and like comfortably know the business will be here next year. It's unbelievable the amount of support that we have gotten with T3 Chat, the amount of help we've gotten from the partners that we work with, the providers that we host with, and the users, each and every one of you that both uses and supports us with the app, tells us when things are wrong, and also shares it with others, causing the service to just keep on expanding and growing. I am relatively confident now that I've done a pretty deep audit that everything we're using today will continue to scale for a very, very long time, but I need to keep a closer eye on this going forward to make sure nothing like this can happen again. I hate outages like this. We're taking this incredibly seriously. I've been working so hard on T3 Chat that my video schedule's been falling apart. We had over 40 videos of backlog. We're down to 5-ish because I've been filming at most 3 videos a week lately and just focusing all in on this. I'm so happy to be doing it again, coding 10 hours a day, almost every day. I shipped a commit or a PR all but 2 days of last month, and I love it. And I love all of you for making this possible. And I hope that outages like this don't keep you from coming back. But I also understand if they do. We need reliable tools. We need things that we use like T3 Chat to be there when we want them, to be there when we have questions, to be there when we need information. And every time it isn't, you're way less likely to come back. That all said, you can't use Claude either, so keep using T3 Chat. I'm very happy with where we're at. I think our stability problem is more than solved here, and we'll be going out of our way to make it so fixing these things in the future takes minutes, not hours. No one is immune to outages. I hope that my language has never implied that we can't go down. And I hope the times I've complained about other services going down doesn't seem like I'm saying they go down and we don't. What I want is accountability and transparency. There was a couple people who tried to dunk on me with this, saying, you were just complaining about Twitter being down. No, I was complaining that Twitter had been down for 3 days, and all of the comms we had about it was a random reply Elon did blaming the server company for burning down. There was no accountability there at all. No ownership, no transparency, no nothing. The thing I care about is the ratio of severity of outage to severity of comms about the outage. We over-communicate small outages. They under-communicate massive ones. And I will always call companies out who make those mistakes because they are inexcusable. And considering the fact that I still can't load my Twitter feed right now, it's absurd to me. People make fun of our downtime. But at the same time, I am so thankful that we have enough users, enough people, literally tens of thousands every day, that use and rely on T3 Chat, that tell us when these things happen so we can get on top of them faster, get these fixed more aggressively, and ship the best possible service to each and every one of you guys. I hope you understand how seriously we take these things. I hope you understand this isn't just a side project for some YouTuber anymore. This is a very legitimate application. It's a very real product for a very real company that I'm taking as seriously as I possibly can. I hope this helps restore some of that confidence and show you what our plans are going forward, or at the very least, you could learn some things about shipping at scale from what I've shared here. Let me know what y'all think, and until next time, stay up.